Okay, so good afternoon, guys. Okay. Yeah, so now our today's topic is titration of (25 ml) of 0.5 molar phosphoric acid versus 0.5 molar sodium hydroxide. Titration of 25 ml of 0.5 molar phosphoric acid versus 0.5 molar sodium hydroxide. So that titration we have to do today, okay? And we have to calculate pH when we add sodium hydroxide, okay? How the pH changes, right? Okay. So take 25 ml initially, pH in the beginning. When we begin the reaction, titration, when no sodium hydroxide is added, then what is the pH? So in the beginning we have 25 ml of 0.5 molar phosphoric acid, right? And it is phosphoric acid solution. So in phosphoric acid we have H plus and H3PO4 negative, or H2PO4 negative to give H plus and HPO4 2 negative, and HPO4 2 negative to give H plus and PO4 3 negative. So value of K1, K2 and K3 play a very important role. Value of K1 is, it is given 7.5 into 10 raised power minus 3, and value of K2 is 6.2 into 10 raised power minus 8, and value of K3 is 4.8 into 10 raised power minus 11. So you can look at these values. See, K1, K2, difference is, ratio is around about 10 raised power 5. That means K1 is 10 power 5 times more than K2, and K2 is 10 power 3 times more than K3. That means main contribution to H plus ion is of K1. मेन कंट्रीब्यूशन किसका होगा? K1 का. K2 और K3 जो है they contribute towards H plus ion concentration but to the minimal amount, बिल्कुल कम, मतलब ना के बराबर. इसलिए स्टार्टिंग में we will take into account only K1. There is no role of K2 and K3 because first of all K1 that value is highest, K2 value is very less, K3 is still very less. That's why main contribution towards H plus ion is of K1, right? So now if you see its concentration, let's take it as C. So it's 0, 0. Now, out of C, X amount is dissociated. So we get X H plus and X H3PO4 negative. So from here, K1 is equal to H plus ion concentration, H2PO4 negative ion concentration, product concentration divided by reactant, 1 equal to X into X divided by C minus X. X is very less as compared to C. So from here C minus X is very close to C as X is very less than C. Okay, so from this it is K1 equal to X square over C. So okay, now it's okay. So tell me, what is the value of 37.5? Square root of 37.5. It is into 10 raised to power minus 2. So what is the square root of 37.5? Yes. Square root of 37.5. Fast. Because 10 raised to power minus 4 square root of is 10 raised to power minus 2. Now what is the square root of 37.5? Very good. It is 6.12. Okay. So this is the concentration of H plus ion. Okay. Now after calculating the concentration of H plus ion, let us calculate pH. You know pH is minus log of H plus ion, that is equal to minus log of 6.12 into 10 raised to power minus 2. So that is minus log of 6.12 minus log of 10 raised to power minus 2. So that is minus log of 6.12 minus plus log 2 plus minus plus 2 log 10. Log 10 is 1. Okay, so minus log of 6.12, that is 2 minus, what is the value of log of 6.12? Very good, beta. What is the log of 6.12? Yes, what is the value of log of 6.12? Fast. It is 0.7. Okay, 0.7867. Means roundabout you can write 0.79, because 0.7867 means roundabout 0.79. So value comes out to be 1.21. So this is the initial pH of phosphoric acid. Very good, beta. So in this way, initial pH is 1.21. Okay. Now come to next. This is pH in the beginning. Now, next, on addition of pH, on addition of (12.5 ml) of 0.5 molar NaOH. So we add 12.5 ml of 0.5 molar sodium hydroxide in this particular solution. Okay. So we have phosphoric acid. So now there is a acid-base reaction. Phosphoric acid, obviously it is an acid. Sodium hydroxide is a base, so acid-base titration takes place, acid-base reaction takes place, and therefore on reaction one of the H plus ion is replaced by sodium and we get this product. Okay, means we are going towards first equivalence point. Okay, when whole phosphoric acid is converted into sodium dihydrogen phosphate. Okay. Now initial number of millimoles. So tell me, how many millimoles of H3PO4 are there? Formula: number of millimoles equal to molarity into volume in ml. This is the formula, and to calculate molarity equal to number of millimoles divided by volume in ml. Like if we have number of moles, then we divide it by volume in liter. Okay. So tell me, millimoles of sodium. Very good. Very good, Raj, Pari. Good. 25 into 0.5. So it is 12.5. Right? Now sodium hydroxide. See, we add 12.5 ml of 0.5 molar sodium hydroxide. So how many millimoles of sodium hydroxide are there? Very good. All of you, great effort. Phosphoric acid, number of millimoles are 12.5 and millimoles of sodium hydroxide, oh, very good, it is 6.25 because 12.5 into 0.5 molarity into volume in ml. Initially they are 0. Now after reaction or after neutralization we can write. So limiting reagent is sodium hydroxide. So how much phosphoric acid left? 6.25. It becomes 0 and it is also 6.25. That means now after reaction we have mixture of phosphoric acid and sodium salt of monosodium salt of phosphoric acid. So it is mixture of weak acid and its salt with strong base. So it is an acidic buffer. It is an acidic buffer. So for acidic buffer we can apply Henderson equation. So according to Henderson equation for acidic buffer, pH equal to pKa plus log of pKa plus log of salt over acid, right? So in this case pKa is pK1, right? Because H3PO4 gives first H plus ion to form H2PO4 negative. It is like this: H3PO4 oblique H2PO4 negative. So first H plus ion is replaced by phosphoric acid. So it is pK1 plus log of concentration of concentration of salt divided by concentration of H3PO4. Okay, so you know volume remains same. So just calculate first pK1. pK1 is minus log of K1, that is minus log of, what is K1? K1 is 7.5 into 10 raised to minus 3. log of 7.5 into 10 raised by minus 3. So that is minus log of 7.5 minus log of 10 raised by minus 3. So it becomes minus 3 minus minus plus. So log 10 3 minus log of 7.5. 3 minus log of 7.5. Right? So yes, tell me, what is the log of 7.5? What is the value of log of 7.5? Yes, fast. 0.875. Okay, 0.87. Okay, so 0.875. So it is 2 point, yes, 2.125. So that is, on rounding off, it is 2.12. So pK1 is, keep in mind, it is 2.12 because it is even number. So if it is 5 and preceding number is even, so that remains same, that does not change. So it is 2.12 pK1. Now you know ratio of NaH2PO4 to H3PO4 is equal to number of millimoles of NaH2PO4 divided by its volume in ml, or divided by number of millimoles of H3PO4 divided by the total volume. So volume cancel. That means ratio of the concentrations is equal to ratio of their millimoles. So what is the millimoles? 6.5, 6.25, and acid millimoles are also 6.25. So cancel out. That means it comes out to be 1. Ratio comes out to be 1. And what is the log 1? What is the value of log 1? So pH is equal to pK1 plus log of 1. And what is the value of log 1? Log 1 is 0. That implies pH is equal to pK1, means pH is equal to 2.12. So this is the answer. Okay, very good. Log 1 is 0, right? Good. So this is when, this is the pH when we add 12.5 ml of 0.5 molar sodium hydroxide. Now PC, pH of solution on addition of 25 ml of 0.5 molar sodium hydroxide. Okay. Now, again we have phosphoric acid and sodium hydroxide to give NaH2PO4 and water. Initial number of millimoles, again 12.5, because 25 into 0.5, that you know all. Sodium hydroxide 25 into 0.5, they are also 12.5. Initially it is 0. Now after a reaction, it becomes 0, and it becomes 12.5. So this is your first equivalence point, because whole phosphoric acid is converted into its monosodium salt. So this is called first equivalence point. This is the condition for first equivalence point. Okay. Now we have monosodium salt of NaH2PO4. Now H2PO4 1 negative. This we have. Okay. So H2PO4 1 negative can give HPO4 2 negative, and its discipline constant is K2, and it is formed from H3PO4, right? And it is K1. So that means it is an amphoteric species. This is an amphoteric species. It can act as a base. It can act as an acid, because when phosphoric acid is converted into H2PO4 negative, this acts as acid. So this one acts as base, obviously. But when H2PO4 negative is converted into HPO4 2 negative, it acts as acid, and HPO4 2 negative acts as a base, right? So it is a base as well as acid, and such species are called amphoteric. Okay. So for this type of species, it is independent of its concentration, and pH is equal to half of pK1 plus pK2. H2PO4 negative, K1 and K2. So pH is half of pK1 plus pK2. Got it? That means there is no dependence on the concentration of the salt. So at first equivalence point, pH equal to half of pK1 plus pK2. You know pK1. What is the value of pK1? It is, I think, what is the value of pK1? pK1 is 2.12. Now pK2, it is equal to minus log of K2. So minus log of, yes, what is K2? Value of K2 is 6.2 into 10 raised to minus 8. Okay, so that is minus log of 6.2 minus log of 10 raised to minus 8. So it comes out to be minus log of 6.2 and minus 8 become plus 8. So 8 minus log of 6.2. What is the value of log of 6.2? Yes. Value of log of 6.2. Yes. What is the value of log of 6.2? It is 0.7923. Very good. So means round about 0.79. So 0.79. So 0.79. So its value comes out to be 7.21. Okay. So from this, pH equal to half of 2.12 plus 7.21. Okay. So half of 9.33. Half of 9.23, that value comes out to be 4.67 around. So this is pH. At the equivalence, at the first equivalence point, right? .665. So round about 4.67. Okay. Now to detect this first equivalence point, the indicator used are methyl orange, okay, or bromocresol green. These are the indicators used in this case. You know, for methyl orange, value is 3.1 to 4.4. Okay, red to orange. Okay, and for bromocresol green, it is 3.8 to 5.4. Okay, range of this, and it is yellow to blue, yellow to dark blue. Okay. So these are the indicators used for first equivalence point. Okay. Now D, pH on addition of 37.5 ml of 0.5 molar sodium hydroxide. pH on addition of 37.5 ml of 0.5 molar sodium hydroxide. So this is the thing, phosphoric acid, the sodium hydroxide to give NaH2PO4 for the first equivalence point. Now you know this is again initial number of millimoles, phosphoric acid 12.5 and sodium hydroxide 37.5 into 0.5 means 18.75. So after the reaction, it is 0. Sodium hydroxide left is 6.25 and NaH2PO4 formed is 12.5. Right? Now this NaH2PO4 can further react with sodium hydroxide because we have sodium hydroxide left for the further reaction. So we get Na2 HPO4 plus H2. This is 12.5 and this one is 6.25 initial. Now after the reaction, how much NaH2PO4 left? 6.25 and it becomes 0 and it is also 6.25. These are the millimoles. Initial millimoles and after reaction millimoles. This is acid and this is soil. Acid and salt. Okay. Now NaH2PO4 become acid and this is soil. So again we get buffer. But which is buffer? H2PO4 negative plus HPO4 2 negative. This is the buffer form. We get this buffer. Okay. Now as we get this buffer, now again we can apply Henderson equation, but concentration of salt, this is salt, to the concentration of H2PO4 negative is equal to millimoles of HPO4 2 negative over millimoles of H2PO4 negative, and that is equal, so it becomes 1. So as it is again acidic buffer, we get acidic buffer. So according to Henderson equation, visible? Yes. According to Henderson equation, pH equal to pKa. Now tell me, what is pKa here? pK1, pK2 or pK3? Yes. Very good, Raj. It is pK2 because now H2PO4 negative is converted into HPO4 2 negative, and that is K2. Okay, so pK2 plus log of salt over acid. And this is 1, so pH is equal to pK2. And what is pK2? That we have calculated. What is pK2? Yes, pK2 is 7.21. So pH is 7.21. That's it. So when we add 37.5 ml of 0.5 molar sodium hydroxide, pH of the solution is 7.21. Okay. If you have any doubt, please do ask anytime. Right. Now, on addition of, now we add the E part, okay, pH on addition of 50 ml of 0.5 molar sodium hydroxide. Yes. So now when we add 50 ml of 0.5 molar sodium hydroxide, now sodium hydroxide is 25, it is 12.5, so it is completely neutralized and we get 12.5 sodium hydroxide and 12.5 NaH2PO4. So now 12.5 NaH2PO4, 12.5 sodium hydroxide. So on after the reaction it is 0, 0 and 12.5. Again we get HPO4 2 negative. Now HPO4 2 negative gives PO4 3 negative, and equilibrium constant is, the rate constant is, dissociation constant is K3, and to get this it is formed from H3PO4 negative and dissociation constant is K2. So you know HPO4 2 negative, it is formed from H2PO4 1 negative, the dissociation constant K2 is K3. So what is pH now? Here pH is half of pK2 plus pK3, right? Half of pK2 plus pK3. Okay, so now you know K3. What is the value of K3? K3 was, yes, what was K3? 4.8 into 10 raised per minus 11. Okay, so pK3 equal to minus log of K3, that is minus log of 4.8 into 10 raised per minus 11, means minus log of 4.8 or minus log of 10 raised per minus 11. So it becomes minus log of 4.8 plus 11. What is the value of log of 4.8? Yes, log of 4.8, 0.68. Okay, great. So 0.68 plus 11. So it comes up to be minus, okay, 10 raised per minus 11. So pK3 is I think K3 is, wait for some time please, K3 value of K, sorry, K3 is 4.8 into 10 raised per minus 13. Okay, starting we have written it wrong, please correct it. It is 13. So 13 plus 13 minus 0.68. So value comes out to be 12.32. Okay, 12.3. Okay, so it is half of pK2. pK2 was 7.21 plus 12.32. So it is half of, yes, 7.21 plus 12.32. So it is 19.53. One, two, three, 2, 5, 2, 7, 9, 19.53. So it is 9.7, 9.76 around. Okay, 9.76. Good. 9.765. So we can take it as 9.76. So this is actually second equivalence point, right? This is second equivalence point. This is second equivalence point, and to detect the second equivalence point we use phenolphthalein, but very difficult to detect. And phenolphthalein and thymol after that we add thymolphthalein to detect the end point, means second equivalence point, or sometimes we add phenolphthalein along with mixture of phenolphthalein and naphthalene in the ratio of 3:1 to detect second equivalence point. In the first equivalence point, we add methyl orange or bromo cresol green. Okay, here we use 3:1 mixture of phenolphthalein and naphthalene in the ratio of 3:1. Okay, so this is all about second equivalence point. Now, next is pH on addition of 62.5 ml of 0.5 molar sodium hydroxide. Now, see, 62.5 molar. So, when we add 62.5 molar ml of 0.5 molar sodium hydroxide, means we have 31.25 millimoles of sodium hydroxide. So initial phosphoric acid is completely converted into NaH2PO4 and we get this is 18.75 and it is 12.5. Okay, now this is 12.5 and this is 18.75. Now after the reaction it is also completely neutralized and we get Na2HPO4 same amount because now it is limiting reagent. So now we left with sodium hydroxide 6.25. That means still we have sodium hydroxide to react with Na2HPO4. So now Na2HPO4 further react with sodium hydroxide and we get Na3PO4 along with H2. Okay, so initial moles of Na2HPO4 is 12.5. This is 6.25. This is 0. Now, see, after the reaction, we left with 6.25 mole of Na2HPO4 and 0 NaOH because it is now this is limiting reagent. Okay, so 6.25. Again we get buffer. Again which buffer? Again acidic buffer is formed. We get acidic buffer. इसका acidic buffer of HPO4 2 negative and PO4 3 negative. In this case it is acting as acid and this is acting as salt. This is salt, this is acid, and salt acid concentration is equal. So pH equal to, now see, it is converted into HPO4 2 negative to give PO4 3 negative by K3 rate. Dissolution constant is K3 for this. So according to Henderson equation, is it visible? Yes. According to Henderson equation, now it becomes pH equal to pK3. Now it is pK3 plus log of salt concentration to the acid concentration, and concentration of salt and acid is same. So in this way, here pH equal to pK3 means pH equal to 12.32. Okay. Wait for some time. Just one portion left. Okay. Now pH on addition of 75 ml of 0.5 molar sodium hydroxide. Now 75 ml of 0.5 molar sodium hydroxide. So 75 into 0.5, that becomes, yes, what is the value? Just tell me. 75 into 0.5, what is the value? 18.75 into 0.5. What is the value? 37.5. Okay. 37.5, then it is 0. Now it is how much left? 25, and it is 12.5. Now it is 12.5, it is 25, right? So after the reaction it is again 0, it is 12.5, and it is also 12.5. Now because 12.5 is neutralized, so it is left 12.5, 12.5. So again 12.5, 12.5, 0, and after the reaction 0, 0, and it is 12.5, right? So now we have only sodium phosphate. Okay, so millimoles are 12.5. So sodium phosphate concentration is equal to number of millimoles over volume. So see, 75 ml of sodium hydroxide and 25 ml phosphoric acid. So total volume is 25 plus 75. Okay, so that is 12.5 over 100. Am I right? Say 12.5, 37.5, 0. So 37.5, 12.5 are neutralized, is 25 millimoles. Now this 25 millimoles react with 12.5 millimoles of NaH3PO4. So we left with 12.5 millimoles of sodium hydroxide and 12.5 millimoles of Na2HPO4, and then Na2HPO4 12.5 is neutralized by 12.5 sodium hydroxide, so we get 12.5 Na3PO4. That means concentration of sodium phosphate is 0.125. Okay, so now as we have sodium phosphate is a salt of sodium phosphate is a salt of, yes, weak acid and strong base. So for this pH equal to 7 plus half of pK, which pK? pK3, okay, plus log of concentration of Na3PO4. This is C, concentration of Na3PO4. So in this way it is 7 plus half of pK3. What is pK3? 12.32. Now log C. Log C equal to log of 0.125. So what is the value of log of 0.125? Yes, tell me. Yes, yes, fast. What is the value of 0.125? Log of 0.125. Rutvik, right, it is 0.9. Okay. Log of it is minus 0.9. Okay, minus 0.9. Okay, so minus 0.9. So 7 plus half 12.32 minus 0.9, 11.42. So that is 7 plus 11.42 divided by 2, 5.71 and plus 7. So it is 12.71. So pH of sodium phosphate formed is 12.71. The value given in your book is it is 12.3. Okay, so there is a bit confusion, but anyhow we can take it as 12.71. So if we plot a graph, for this titration, and this one is third equivalence point. It is very difficult to detect this equivalence point. Okay, pH and volume of sodium hydroxide. This is like it is like this. Say in the starting pH equal to, we can write pH equal to, here pH equal to pK, H plus ion concentration, square root of K1 into C. Okay, then pH equal to pK1, at midway pH equal to, in the starting it is like this, then in the mid pH equal to pK1, then pH equal to half of pK1 plus pK2, then pH equal to pK2, because again buffer is formed. This is buffer solution, again buffer is formed, and then pH equal to half of pK2 plus pK3, then again pH equal to pK3, and then pH equal to, yes, 7 plus half of pK3 plus log C. Okay, so in this way there are 3 equivalence points in the titration of phosphoric acid versus sodium hydroxide. Right? So thank you very much. God bless you all. Happy learning. Jai Hind, Jai Bharat. If you have any doubt, please do ask. Any doubt? Any doubt, beta? Okay. No doubt? That's great. You all are very intelligent people. Okay. How to use mixed indicator? Because a mixed indicator means, universal indicator. That is also a mixed indicator. Means we mix the indicator in the ratio assigned to us, and that is called mixed indicator. Universal indicator is the best example. Okay, because some indicator has range of, like phenolphthalein 8.3 to 10. Some indicator have range from 4.1 to 5.3. So they give different colors at different pH. Just like pH paper. Okay, so this mixture is just like pH paper. You know, pH paper give different colors in different pH. Got it, Raj? Okay, okay, so please like the video. Bye bye.